Imagine you're out in the wilderness exploring, miles and miles of roads that is perfect for your off-roading vehicle. You come to a fork in the road. The right seems to be the way that is most traveled. The left seems to be grown over with grasses, but you can still see the clear outline of a road. It still looks like a road. What do? Do you go the route most traveled, or the route less traveled with an unknown destination? This is a common picture in the Taylor Park area. The Forest Service has been hard at work to decommission or close these roads that were created by off-roaders. To seed or not to seed? That is the question. Hi, my name is Brittany, and my project was monitoring vegetation and ground cover on decommissioned roads in Taylor Park, Colorado. National Forest roads are an important part of the national forests in the U.S. They provide access for people recreating and Forest Service employees. The number of people participating in outdoor recreation is increasing. In Colorado, OHV use is on the rise, meaning more people are utilizing these national forest roads. These roads negatively impact the ecosystem by creating an unfavorable condition for vegetation growth by increasing erosion, soil compaction, and runoff. They also degrade the watershed and decrease water infiltration of soil. Wildlife are also affected because they cause habitat fragmentation, which leads to prohibiting movement and increasing the chance of disturbance from humans. Management of these roads is critical to preventing these negative impacts. One of the ways the Forest Service manages these roads is road decommissioning. Decommissioning is the removal of a road and returning it to its state before the road was created. There are several different decommissioning treatments that have been used. One is placing a physical barrier in front of the road. One is drainage, which just means getting rid of structures that redirect water underneath the road. Prism, which is contouring the road, eliminating the road entirely with heavy machinery as shown in these pictures. Ripping is another technique with heavy machinery, but this just stirs the soil on the road and mixes it together to get rid of compaction. There are also vegetation treatments, which is seeding on the roads to encourage revegetation. Depending on the location, type, and landscape, this is what determines what technique should be used. Monitoring the road recovery following the treatment is really important to determine what treatment is best in the long run. An important thing to consider when deciding the decommissioning technique is the type of landscape and vegetation community. Usually the main goal of decommissioning is to prevent erosion and runoff. Recontouring has been found to be an effective method to prevent these, but many studies state that seeding is also best for preventing long-term erosion. Before picking a seed type, like native or non-native, it's important to know how susceptible the native vegetation is to invasive species. In the Gunnison National Forest, it is unknown what decommissioning technique works best. Roads previously closed are still visible. Vegetation growing on the road is different than the native plant community adjacent to the road. The Forest Service uses several different techniques to close the roads. They use physical barriers, ripping, and seeding. As seen in the picture, you see a road before ripping and then after ripping. Sometimes they use a combination of these treatments or only one. The type of treatment is case by case depending on the time and money for the project. Again, the main goal for this project was to answer the question, to seed or not to seed? The main purpose of our study was to evaluate seeding as a decommissioning technique on roads in Taylor Park. How do decommissioning treatments influence vegetation composition? How effective is seeding versus not seeding in restoring vegetation and preventing the establishment of non-native species? Does this seed mix encourage or discourage the growth of native plants? What plants are growing on these closed forest roads? The Forest Service plans on closing more roads in the future, and the results of the study will directly apply to current management decisions on whether or not they need to buy a seed mix for road restoration. Taylor Park is in the Gunnison National Forest, about 29 miles northeast of Gunnison, Colorado. The roads in the western area of the park were seeded in the blue, with a 4-seed mix of native plants: blue wild rye, mountain brome, San Luis sunder wheatgrass, and sandberg bluegrass. The seed mix was selected by the U.S. Forest Service botanists because of their success in restoration. The eastern portion of the park was not seeded, in the red. We randomly selected 15 segments that were seeded and 15 segments that were not seeded. A control segment was made for each of the seeded and unseeded segments, making a total of 30. Line point transect method was used to record vegetation and ground cover. 50-meter line transect was placed in the middle of the road, and then another 50-meter was placed adjacent to the road at least 30 meters away. That was the control transects. A point was recorded every 0.5 meters, so each transect had a total of 100 points. At each point, a pin was dropped, and whatever plant that came in contact with the pin was recorded, and the type of ground cover. The box plot on the right shows the presence of functional groups in each treatment. The x-axis is treatment, and the y-axis was percent composition. The percent composition of different plant functional groups was calculated to analyze differences between seeded, unseeded, and control segments. As you can see, the seeded segments had more graminoids, and they were not the same as the control segments. The unseeded segments were more similar to the control, and the unseeded and seeded were very different. Seeded segments had more vegetation cover than the not seeded segments, and the not seeded segments had no seed mix plants. The box plot on the right is the ground cover composition for each treatment. 4 ground covers were recorded: bare ground, litter, other, and rock. As you can see, bare ground was highest on seeded and unseeded, and litter was highest for the control. What we found was road disturbance increases bare ground. Bare ground was not similar in seeded and control, and also unseeded and control. Unseeded and seeded had a fair amount of the same bare ground presence. This box plot shows the native and non-native plant presence for each treatment. As you can see, the control transects had close to 100% of native plants present. The unseeded had the most variation in both native and non-native presence. Seeded had more native plants present and less non-native plants present compared to the unseeded transects. For non-native plants, seeded had about the same amount as control. Unseeded had way more non-native plants than control. And unseeded and seeded had different levels of non-native plants present. To go over our findings, the native 4-seed mix increased graminoid presence. Road disturbance increased the bare ground, and seeded transects had less non-native plants than unseeded. Based on what we have from this 1-year study, we recommend seeding the roads is the best approach to establishing vegetation cover. It decreases non-native plant presence, and other studies have also shown that seeding leads to an increase in vegetation cover, leading to a decrease in erosion and non-native presence. We recommend to continue to monitoring roads to see if seeding continues to lead to vegetation like the surrounding habitat. This project would not have been possible without the help and support from my committee members, Dr. Jenny DeMarco, Dr. Phil Crosley from Western Colorado University, and Ashley Holm from the Forest Service. I also want to thank the MS in Ecology Statistic peer tutoring for helping me with all my steps. Thank you.